Today, we're looking at cubics, all right? But the thing about cubics is, and what we're going to look at today with cubics is, all of the rules we look at, we've seen before when we've looked at quadratics. It's now just going one step further for cubics, okay, or a little bit different. But all of the rules are the same for cubics as for quadratics. So everything, if you get the rules for quadratics, today's lesson should be really simple for you. If you don't, then today's lesson's a review and you need to ask questions, and we'll try and make sure you do understand it. Hopefully you'll be better at both cubics and quadratics by the end of today's lesson. So the first thing we're going to look at is we're going to look at a cubic from a table, okay? So if we look at y equals x cubed and we draw a table for this. We should be able to, because we've been given the equation, be able to fill in this table. So what's 0 cubed? 0 times 0 times 0? 0. What's 1 cubed? What's 1 cubed? 1. What's 2 cubed? 2 times 2 times 2? 8. 3 cubed? 3 times 3 times 3? Is that louder? 27. Okay. We need to work on that. Alright, so at least you answered. That's what matters. So, if we go with -1, so -1 cubed. -1 times -1 times -1 is -1. -2 cubed. -8. -3 cubed. -27. Alright. So, if you got given the table and you didn't get given this equation, you only got given the table, you need to be able to, as part of the syllabus, you need to be able to work out whether this is a linear function, a quadratic function, a cubic function, and then later on an exponential or a reciprocal function, okay, from the table. Now, how did we work out if something was linear or not? It goes up, has a first difference pattern, yeah? A common first difference pattern. So, we check that first. So what's the difference between -27 and -28? What have we done to get there? We've added on 19. What about -8 to -1? 7. -1 to 0? 0 to 1? 1 to 8? 7? 19. Okay, so that's the first difference pattern. So, is this a linear function? No. So we go, nah, not linear. Okay? This is the process you have to go through every time you get asked to check this, okay? We first check linear. How do we check if something's quadratic? How do we know if something's quadratic? It has a second difference pattern, which means if I then look at the first difference pattern, is there a similar number each time here? So, 19 to 7. How did I get from 19 to 7? 12. I took away 12, right? Take 12. What about 7 to 1? Take 6. 1 to 1? 1 to 7? 7 to 19? 12. Are they all the same number? No, so therefore it's not quadratic. And that's how you check if something's quadratic. So you check if it's linear, is that number all the same? No. You check if it's quadratic, is that number all the same? No. What do you think we do to find out if it's cubic? Third difference pattern, okay? So, -12 to -6, we add 6. -6 to 0, 6, 6. We have a common third difference pattern. And that means, yes, it's cubic. And that works every time for every cubic. Okay, same with for quadratics, that second line will always be the same. For linear, the first line will always be the same. So, can you just write cubics always have a common third difference pattern. And that almost always comes up in tests and exams. You just get given a table and ask you to tell what sort of function it is. You don't have to work out the equation from that. You just have to be able to graph it from a table and be able to tell me if it's cubic, quadratic, linear, exponential, reciprocal. Are there any questions about that? Do I need to go through another example, or are you okay with it? All good. Okay, let's move on. We're going to leave all the questions with that until we've actually done all the different functions. So then I can give you a table and you can work out 1 out of the 5 which type of function it is, rather than do each one separately, which will just take up too much time. All right, so today what we're now going to look at are translations. So translations when cubics are in turning point form. Remember how quadratics had all those 2 different forms? Okay, this is how cubic's written similarly. Now I'm going to use the same website we used for quadratics to demonstrate this. So can anyone remember what translations mean when we looked at translations of quadratics? Good, it's when like the function is inverted or moved up and down, left and right. Okay, same rules apply for cubics, and they're actually the exact same rules. So this should be a review, all right? So let me just grab this website up. All right, this website, I'm pretty sure you have a link to last semester. But we did this website for quadratics. Today we're going to look at it for cubics. So, first one, x cubed. That's what it looks like. That's just what we need to know about. That's what x cubed looks like. So could you just do a quick sketch of that? Because everything from now on is going to be in comparison to that. We don't have to write it every time. So you just do a quick sketch of what it looks like. It's in that direction. It goes through, what point does it go through? 0, 0, okay? So this is what y equals x cubed looks like. It goes through 0, 0. That's going to be our comparison, okay? So all the sketches we looked at yesterday or Monday were in factor form, so where they had those sort of 2 turning points, okay? This one, if we call it a turning point, it's that 0, 0 point, okay? That's what everything's going to move. That's what's going to move left, right, up, down, and be inverted around, okay? That 0, 0 point. Are there any questions about that? All right, so let's have a look at what happens when we change from y equals x cubed to y equals negative x cubed. What's going to happen? It's going to be inverted, okay? So it's going to have a negative shape. We've already looked at what a negative shape looks like. So if you have a look, this is positive. This is negative. You see the difference? Negative, positive, negative. Okay? So it's inverted. So, when x cubed, can you write something like this down, please? When x cubed is negative, the function is inverted. So for example, y equals x cubed goes to looking more like this, in that direction. Okay, it's not perfect, I know. Yes? Oh, I've just written when x cubed is negative. Oh, this here. Yes, you're right. Sorry. That would be better. Thank you, Zen. Is everyone okay with that rule? We looked at it on Monday. So it's the same rule as with the quadratic. Remember, if x squared was negative, it was inverted. Same deal for this. Anything at the top moves to the bottom, anything from the bottom moves to the top. Alright, next bit. What happens, what do you think happens when we add or subtract a number from the x cubed? So when I add a number, so for example, x cubed plus 2, what's going to happen to x cubed when it goes to x cubed plus 2? Jack, what's going to happen? Okay, what else could happen? Rory, what could happen when I change it to x cubed plus 2? Could? Lockie, what's going to happen? It might. Jared, what's going to happen? It's going to go up. Any other ideas? Yeah. Oh, yeah, it might be dilated. Let's have a look. So when we go from x cubed, which is what's there now, when we go to x plus x cubed plus 2, it moves up by 2. Good work. Okay, it's the same rule as quadratics. When you add a number at the end, when you add a number to the x cubed, it goes up. So what's going to happen when I go x cubed take 3? It's going to go down by 3. So if we look at that, down by 3. What's going to happen when I go negative x cubed plus 1? Julian, what's going to happen? Good, it's going to be inverted and then up by 1. Everyone see that rule? So can we write some notes down about that, please? So when a number is added or subtracted from x cubed, if it's added, it moves up. If it's subtracted, it moves down. Yeah. 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 So if it's already inverted, it's still the whole inverted function which moves up if it's plus. So none of these things they all work independently of each other. So they don't react to each other. Does that make sense? Okay. So, for example, let's just do these 3 examples, okay? So we'll go y equals x cubed, let's go plus 4. What's going to happen to our line if it's x cubed plus 4? It's going to go up by 4. That 0, 0 point is going to become 0, 4. So it's going to look something like that. What's going to happen when I go y equals x cubed take 2? It's going to go down by 2. So that turning point is going to go down by 2. So it's going to be 0, negative 2. Same shape. Just going to go through that point instead. Last one, y equals negative x cubed plus 1. Good. So we're going to invert it. And then it's going to go through that plus 1. So it's going to go through here. 0, 1. And it's going to be inverted, so it's going to be the other direction. Are there any questions about that rule, Lucas? We're going to get to the next bit next. That bit next. Okay? It will always be x cubed, or it will be in brackets cubed, which is the brackets is what we're going to look at next. Jack, have you written all that down? Okay, any questions about that? Okay, last one we need to look at. What's going to happen when inside the brackets there's a number added to x or subtracted from x inside the brackets? Ben? Good, we're going to move left and right. Now, if I said x plus 2 cubed, which direction is it going to go in, left or right? Left. Why? Why is it going to go to take 2 instead of being plus 2? In the equation it says plus 2. Why? Yeah? Good, because what we're actually finding is the root of that line. So we're actually just going x plus 2 equals 0, x equals negative 2. The other way of thinking about it, which is not the specific mathematical way, but if it's in the brackets, it's the opposite sign. And that works for all times, okay? So, x plus 2 cubed, it moves to the left by 2. Can everyone see that? So from there to there. What's going to happen when we say x take 2 cubed? Moves to the right by 2. Someone further towards the back, what's going to happen when we go negative x plus 1 cubed? Jack, what's going to happen? Yep, and move 1 to the left. Can everyone see that? So we just need to write some notes about that rule. So when a number is added or subtracted from x, then cubed. Okay, so that means it's in the brackets and then it's cubed. If something's added, we move left. If something's subtracted, we move right. Can you write that down, please? Okay, so the first one, x plus 5 cubed. What's going to happen to that? Left by 5. Thanks, Jack. So that root there will be 5. X take 3 cubed. Dan, what would x take 3 cubed do? Good? By? Good. And the last one, David, how would you be able to do that? Move to the left by 1 and left by 1, and it's also inverted. Okay, so left 1. So negative 1, 0. And it's inverted, so it comes from this direction now. Any questions about that? We are going to look at one more thing quickly. It's not as important as the others, but we'll just have a quick look. What do you think we also need to look at now? We've gone left, right, up, down, inverted. We need to look at our dilation, okay? So, it's combined. We'll look at that in a sec. Oh. All right, so what's going to happen when we go to 2x cubed? it's going to become sort of steeper. Okay? Can you see that? 3x, it's even further steeper. So go normal, 3x cubed. Can you guys see that? Normal, 3x cubed. Normal, 0.5x cubed. So 0.5x cubed makes it go wider. Numbers make it go steeper. Now, can you see where x equals 1? Can you guys remember this from quadratics? When x equals 1 for each of these. For this one, what does y equal when x equals 1? 1. Okay, can everyone see that? Can you guys put your eyes up for a second, please? What does y equal when x equals 1 right now? 1. Okay, and this is for x cubed. Have a look at the graph. Jack, you missed this for quadratics, so it's important you look. Okay, so have a look at the graph. This is x cubed. When x is 1, y is 1. Now, if we look at 2x cubed, when x is 1, what does y equal? 2. When x is 1, what does y equal for 3x cubed? 3. Can you guys see that connection? So what's y going to equal when x equals... Sorry, when x equals 1, what's y going to equal in 0.5x cubed? 0.5, can you see? How it goes through 0.5 now? That's where you can work out what's happening, okay? So, we'll have a look at that again in a second if you want to. So, dilation. When the number before x cubed is changed. As the number gets bigger, the function gets narrower. As the number gets smaller, so in terms of decimals, the function gets wider. Look at what y equals when x equals 1 to work out the dilation factor. Now, dilation factor means the number before x cubed. So, for example, this one needs to be a bit more to scale. If that point there is 1, 2, if you can see that point there, and this one still goes through 0, 0, then I know that that will be y equals 2x cubed. If instead it goes through that point there, at 1, 3, I know, and still has that turning point 0, 0, I know that that will be y equals 3x cubed. Can everybody see that? It doesn't work for other points. It only works from going from your turning point to 1 across. But that was the same rule we looked at for quadratics. Is everyone okay with these rules? It's really important you understand them because these same rules, I've said they apply to quadratics, they apply to cubics. We're going to look at them again for exponential functions and again for reciprocal functions. They're the same rules every time, so you need to memorise them. So, last quick question. We're just going to quickly describe a couple of different cubics. So, describe how the following functions have changed. From y equals x cubed. Okay, so you don't have to draw it, you just have to describe it. So, instead of y equals x cubed, what's changed? To that, what's changed? To that? That's probably all we need to do. We'll just look at those two. So I'll just let you finish writing and then we're going to answer those questions. So can you guys try and answer them for yourself? What's changed? Can everyone read that? Or you need to go even further up? I'll do that later. Does anyone still need this? Yes? Which one? Describe. So it's negative bracket x plus 3 cubed, take 2. 4x cubed plus 5. Oh, sorry. Sorry, Dan. All right, can we just quickly answer this? Then you can have time to write because this is our last thing we're going to do right now. Okay? So, what happens to the first one? I need 3 different people to tell me 3 different changes. Lockie? It's inverted. Lucas? Down by? 2. Moves down by 2. Third thing, Ben? Left by 3. Okay, the one below it, what happens to it? Yeah.
It shrinks so that when x equals 1, y equals 4.
Yep, so it gets narrower by 4 times. Okay. Yep, and that's good. So one of the points will be 1, 4, which is good to know. One other thing, what else happens to it? Up by 5. Everyone okay with this? Okay, your homework is you can now finish the booklet from the other day. So you can do the front page of Monday's booklet. Plus, with your calculator, the sheet I gave you today, I want you to do the calculator section. So just that one page. So question 11 from the exam sheet. I'm going to call that the exam sheet because it's from last year's exam. Okay? So, plus question 11 from the exam sheet. You may use your calculator for the question 11. You may not use your calculator for the sketches. Okay? Good luck.